something together. We're going to basically write a smart contract that keeps track of make it so that it keeps track of debt or something. IOUs. Let's say you have like 4 roommates and you go out, you eat outside all the time, and you can use the smart contract to kind of keep track of who owes who how much money, that kind of stuff. If we have time, I'm sure we will. Okay. Okay, so let's get started. My name is Jack. So this I reused, so I created those slides for ITB 256. The class is about Bitcoin because we use Bitcoin as a case study, as a blockchain case study, because Bitcoin is the first application or implementation of the blockchain technology. So it's a good place to start. Also because it's so simple. All it can do is transfer funds, value, transfer assets. There are no like programming capabilities to it. That's why we start off with that. But there is one class section that's dedicated to Ethereum. Basically, in that one, we basically kind of try to go over this really quickly and then to basically give people some exposure to Ethereum. But here we're going to kind of go into it in more detail. And if you don't understand some of the stuff, that's fine. I have everything recorded on my YouTube channel. I can give you guys a QR code or something at the very end. But the benefit of being here is that you get to ask me questions, especially if you've never programmed before. And if you haven't, then that's totally fine because in order to take 256, you don't have to know how to program. Okay. Yeah. So no programming stuff. No knowledge needed. Okay. So let's go over some keywords first, right? Key terms that you kind of need to know in order to have a more educated conversation. First, what are variables? So a variable is basically something you define to store information in, right? So let's say I want to describe my grade in English, my grade, yeah. So and of course this is not how a normal person would say it. But if you want to be really descriptive and weird, you can say my grade, which is a non-negative integer, is 70. So as a normal person, I'll just say I got a what is 70? I got a C minus. But this is how you should kind of speak to a computer, because a computer doesn't know anything. So you have to be very descriptive about what you're trying to tell it, what you're trying to say. So if you describe your grade, my grade in Solidity, which is the language that Ethereum uses, what we have is we basically say U in 256 grade equals 70. Now, what does that mean? So let's break it down, right? So U in 256 grade equals 70. What does U in 256 means? UN stands for Unsigned Integer. I'm assuming everyone knows what an integer is. But what does unsigned mean? Unsigned basically means there's no sign in front of it. So there's no sign in front of 70. The only sign you can have is a negative sign. So unsigned integer basically means it's a non-negative number. Because you don't write a plus sign in front of a positive number. So unsigned just means non-negative, right? 256 bits. So a bit is basically in computer science is a 0. It can be a 0 to 1, and with zeros and ones, you're able to represent numbers in binary. So the system that we normally use, what's it called? Like the system that we use, like we go up every 10 numbers.
Base 10.
Base 10. Let's call it base 10. Yes, decimal, I guess. Yes, base 10. So in the binary system, it's base 2. So you go up once you reach 1. So you start from 0 and you go up to 1, and then if you want to keep increasing, you write 1 0, because the max value is 1, and then 1, and then 1 1, and then 1 0 0, 1 0 1, 1 1 0, 1 1 1, 1 0 0 0, that kind of stuff. Did I get that right? Industry kind.
Yes.
Okay. So this is what's known as the type. This is basically to tell the computer what type of variable this is. All right. And after the type comes the name, right? The name, you can name it whatever you want to. You can name it grade, you can name it score, you can name it whatever. It's the name that you give to the variable. This name is meaningless to the computer. It doesn't care. Gosh, I was going to say, just like how your name doesn't matter to parents. But the computer doesn't care what this is, right? You can define it whatever you want to, but there are certain rules. So you cannot start it with a number. It has to start with a letter, and it has to be an ASCII character. Not even ASCII. It has to be like a alphanumeric, I think. So you can't have like Korean or Japanese, at least not in this language. This is strictly for your own reference. If you want to modify this variable later, if you want to read from it, you have to refer to it by its name, right? And equal sign, I can't really, it's an equal sign, right? It's used to assign the value that's on the right side to whatever's on the left side. So so this basically says, it basically says this variable is 70, right? And 70 is the value that you're trying to assign to the variable of that name of that type. Okay. And there's always a semicolon at the very end. And that basically denotes in Solidity the end of a line. Not really, the end of a statement, I think I should say. The end of a sentence. Because programming languages code is essentially an essay that's both human readable and computer readable. Because at its essence, why do you write code? You write code so that the computer can do something that you want it to do, right? So you can just think of it as instructions for an essay for the computer to read, which you created. So we talked about UN256. That's usually how we represent numbers in Solidity, right? And there are like int 256 and int whatever. So the 256 after the int, as I said, it represents the length of the bits. So let's say if I have a uint1, then you can only represent two numbers, 0 and 1, because you only have one binary number. You only have space for one binary number. If you have uint2, then congrats, you can go up to 4. Is it 4 or 3? It's 3, I'm sorry. So if you have a uint2, then you have two. You're able to hold two binary numbers. So the max you can go is 1, 1, and 1, 1 in binary represents 2 plus 1, so it's 3. All right. So uint256 basically is 2 to the 256 minus 1. That's the max number, which is a huge number. You're never going to reach that number almost. But there's also int 256. And int 256 basically means that it steals 1 bit away. It steals 1 bit at the very front to be used as a positive or negative flag, as a sign, right? And that way, so if it's an int 256, then your range gets cut in half because you also have to split it to the negative side. And also you sacrifice like 1 bit. So that's like the number. That's how we represent numbers. Fun fact: there are no decimals in Solidity. They're all integers. No decimal, like no floating points, no doubles, no decimal points. The reason for that is the base units of, let's say Ethereum, right? You can say, well, I can have 1.2 Ether, right? How does that work? So Ethereum has a base unit called Wei, and 1 Wei equals 10 to the 18th. No, that's the opposite way. 1 Ether equals 10 to the 18th Wei. So every time we represent, we write. So if I want to represent 1 Ether in Solidity, it has to be 10 to the 18th because the unit is actually in Wei, and Wei is the smallest unit. You cannot divide it. So that's why Solidity does not have like built-in like a decimal unit or something, decimal points, because 1 is literally the smallest unit. We also have like the type, again, coming back to the type without all the tangent there. So there's also address. That just represents an Ethereum public address. So whatever you give to your friends when you try to solicit money from them. Bytes 32, okay, this is interesting. This is basically a 32-bit long kind of So it's you can think of it. So bytes 32 can at most hold 32 letters. It represents a 32-byte word. Now, why is it specifically 32? This is because of hashes. So who here knows what hashes are? Yes, who wants to take a shot at explaining what hashes are? Industry time.
I don't know. I'll have to look up the definition.
Yes. Who here wants to take a shot? It's fine, you know. This is a safe space. You can talk about
It's
everything.
basically like mathematically like mapping some information. It's like another one.
Yes.
So sometimes you can have collisions, but generally for like SHA-256, it maps like a unique thing that you can't reverse back to.
Yes. Yes, exactly. So that's kind of how a hashing algorithm works, or what it is. You can just think of it, for the less technical people, you can just think of it as some kind of fingerprint for your data. And there are a few unique properties about hashes. So the first one is that it doesn't matter how big your input or how small your input is, the output will always be, at least in the case of SHA-256, it will always fit within the 32-byte word. It will always be 32 bytes, exactly 32 bytes, right? Doesn't matter like if it's just a 0 or if it's like the entire Romeo and Juliet book in string form. It doesn't matter. It doesn't matter how huge the data source is. It will always get hashed into a 32-byte word, right? And the second thing is that hashes are irreversible, and it's not like encryption. So some people confuse encryption with hashing. So there are two different things. In encryption, there's always a way to decrypt. In encryption, there's no loss of data happens in encryption, because the whole point of encryption is so that you can decrypt it later. But for hashing, as you might have guessed, because it doesn't matter what your input is, you always get the 32-byte word. So let's say I have the whole Bible. I'm hashing the whole Bible, and it also goes down to a 32-byte word. So there's a tremendous loss of data there, and there's no way to go back. Right? It's just, you can think of it as you're able to uniquely identify each person with their fingerprint, but you can't reconstruct the human out of the fingerprint, if that makes sense. Yes. So that's, yes.
Is there a particular reason why it uses 32 bytes to store it?
Okay, so it uses 32 bytes because SHA-256, yes. So I think they're stored in, I think SHA-256, they're stored in, so each character takes up 8 bits. So 256 divided by 8 is 32 bytes, kind of. So 32, so it fits very snugly within the 32 limit. And this is intentional. And the reason why they chose SHA-256 is because Bitcoin used it. And that's like the that's like the standard, I would say. Not really standard, but it's the one that's the most compact, and yet the one that hasn't been broken yet. You had a question?
Is the hashes like how the blocks are connected?
Yes, that's one part. Yes, so blocks are connected together using hash pointers. So they point to a hash, and then you look up that block using the hash. And the reason why it works, and the reason why blockchain is called a blockchain, is because, and the reason why it's temper resistant or something. It's like you can't modify things in the past. Is because if you modify something, then your fingerprint will change, and the next block that's pointing to your previous block would no longer, like, it will have different hash, and then it will point to the next block would end up pointing to nothing. So the block kind of break from there. So you have to reconstruct the whole thing, everything after whatever you messed with. And doing that takes time and resources. And this is why blockchains are kind of tamper-proof. But by the time you have the computing power to beat all the other, to beat 50% of the validators on the network, like you would have used up so many resources, you might as well just play by the rules. Yeah. So that's like, there's like an incentive for you to not cheat in blockchain, right? I was going to say something, but I totally forgot. Yes. So as Randall said, hash collisions. So that's definitely possible because, again, it's a 32-byte word, so 256 bits, which means that there are 2 to the 256 minus 1 possible combinations. It's not an infinite number. So at some point in the future, something is bound to collide with something with another thing. Like they're bound to have the same hash by accident, because you have because on one end you have like an infinite pool of data, and on the other end there's 2 to the 256. So like it's it's not possible to not have a collision. But SHA-256, because the hash pool is large enough, it's so large that we haven't found a single one yet. But for SHA-1, people figure out a way to break the algorithm and produce collisions on purpose. And the danger of that is that if you're able to produce collisions on purpose, then you're able to forge documents, and then you can modify a signature, or you can modify your bank balance or whatever, and then you can curate it in a way that it still has the same hashing and say, okay, well, look, it's the same hash, so it must be, I haven't tampered with it. Whereas in reality, you have, right? So that's the danger of having hash collisions. So I believe SHA-1 is SHA-128, right? I think it's 128. Now you might think, well, okay, 256, it's just twice of 128. So it's probably only twice as safe. Why are we using this? It's actually not. Because 256 and 128, they represent the number of bits. So it's actually twice as hard if you go from 128 to 129. And then twice as hard from 129 to 130 because you're increasing one digit, one binary digit. So it's actually 2 to the, how many times is that? It's like way harder. It's like much harder to break it. They're way more. I think 2 to 56. I think that number is so huge. I think it's more than the number of atoms that exist in the whole universe.
Isn't it just 2 to the 128 times 2 to the 128?
Yes, it's that much harder. So it's literally quite hard to
Just
break.
that squared, pretty much.
Huh?
Just 2 to the 128 squared.
Yes, which is a lot of difficulty to add on. But there are SHA-512. I don't even know if there's SHA-1024. I mean, you could just go on and on, but the fact is, if you go to 512, then you have to double it. This has to turn to 64 bytes. And what that means is that it takes up more space on the blockchain. And space on the blockchain is very precious, because the nature of the blockchain dictates that whatever is on there cannot be changed. So it's like an append-only data structure where you can only add things to it. You can't delete things from it. Because once you do, then you're modifying the past. And if you modify the past, as we said, the hash would change and the entire chain would break. Okay, so that's bytes 32. Really went off tangent there. Okay, now there's also a Boolean value. So a Boolean is just true or false. Fun fact, underneath it's actually a uint 8. I don't know why they did a uint 8, because you literally just need 0 or 1. But that's how they did it. We already went through 256. And the last thing that's very interesting is the mapping. So a mapping, basically, you can think of it as a dictionary, where you can map one element to another element. I'll show you. There's a visualization that I did that I think is pretty interesting. All right. Like so much effort put into this. Okay, so mapping is like, right? So to declare a mapping, so because mapping is mapping one thing to another thing, you have to tell the mapping first, what are the two types you're trying to map? So in this case, we're trying to map a number. Let's not say uint, whatever, just call it a number. We're trying to map a number to a string. A string is just some random letters, whatever. So you're trying to map a number to a string. You can even think of this. So let's say you're reading a book. Your page number is essentially a map. Let's say you're reading like the catalog. I totally forgot what it's called. The table of contents. A table of contents, it is a map itself. It tells you which page is mapped to what chapter. You can think of it that way. And then when you look it up, you look at the page number, you scroll to that page, and you find that chapter. So that's like a nice way to think about mapping, right? All right. So now we're mapping a number to a string, right? So basically, so I can map 0 to my name, 1 to Chaz, or I can map anything. It doesn't have to be consecutive. As long as it's within the range of 2 to the 256 minus 1, which is an infinitely big number. It doesn't have to be consecutive. I can match this is so low res, I can't tell what this says. You can match number 1, 2, 3, 2, 4, 6, 6. Yeah, as I said, I have to zoom in because it's so bad. Okay. I can match this number to some random other string, doesn't matter. It doesn't have to be in order. You can skip keys all you want. So the numbers here, so these are called keys. These are called values. You use the keys to find the values, if that makes sense. It doesn't have to be in order. But the difference between if you know programming and you work with other languages, you know that in most languages, they're not called mapping, they're called dictionaries. And dictionaries or mapping, maps. Most maps or dictionaries, they are iterable, which means you can iterate through the keys or the values to get like one or the other. In Solidity, you cannot. Right? You cannot iterate through a mapping. It does not keep track of the keys. It does not keep track of a list of keys. There is a way for you to implement that, but it's more complex and it requires more storage and more gas. But by default, it doesn't. So if you don't know what your key is, then you're never going to get the value. That's one thing that's special in Solidity, right? And again, yes. So you need to know the exact key for the value, and this mapping maps an unsigned integer to a string, right? And then when you want to set a value with a key, so getting the value with the key, it's just so what we do is we can just, because we're trying to get the value right through using the key. The value is a string, the key is a number. So remember how we declare variables: type, name, so string, val, that's just stand for value. You can call it whatever, you can call it industry type, I don't know, equals, and A is the name of the mapping. I assign, so A is the variable name of the mapping. A mapping is also a variable, everything's a variable. And then you use the square brackets, and then you basically put the key in there. And in Solidity, if it doesn't find anything, if that key points to an empty value, it'll just return to you, it will just return a default value. In this case, the default value for a string is just an empty string. The default value for a Boolean is false. The default value for a number is 0. That kind of stuff, right? And then you can also set a value with a key, right? And a value. So A at, so you can think of it this way: mapping A at key equals this value. So that's one way to define it. And don't worry, I'm just kind of getting you guys familiar with these terms. We're going to write some stuff in a bit that's going to make a lot more sense, because talking about concepts, it's a little bit dry. I know it's a bit dry. And you can even have nested mappings where you have a mapping inside a mapping, and this opens up a lot more possibilities in terms of building out complex data structures. Give me a second. I need to drink. Sadly, I am human. Only human. This is actually quite good. It is the only coconut water that I like. Okay, so in this case, we have a nested mapping, all right? A nested mapping, basically, as I said, a mapping within a mapping. So in this case, we're mapping a number to a string, which maps to a Boolean, right? And I have it visualized here. I have to zoom in. This is 2021, and this projector is like 720p. So I'm mapping a number to a string to a Boolean. A number to a string to a Boolean. As you can see, for every level I kind of get into, I can have like way more stuff, right? And you can think of this as like a class roster almost. Oh, attendance. Yes, that's exactly. You can have the class code, or rather, not attendance, but like room tracking, whatever. You can have the room number. You can have the student name. You can have if they're present or not. Think of it that way. So and you can nest like all like how I actually don't know how many layers you can nest, because I've never gone above like 4 layers. But yeah, so you can have nested mappings essentially. And the keys again keys can be random. Like they don't have to be in order, consecutive. Yes, they're very, very useful because you can use them to build out really cool, really complicated data structures, right? And the way to access them, right? Let's say to access this one, Dark Viper AU. Anyone watched his GTA 5 speedruns? So bool value, it's a bool because I eventually map to a bool, and I'm trying to get the final value, right? Bool value equals A, which is the name of the variable that holds the mapping. And first, I want to go to 200, which is this. A at 200 gives me all these. At .library AU narrows it down to this one, which points to true. So this variable will be true, right? And feel free to interrupt me if you have any questions. Even if, I always say the only dumb question are the ones that are not asked, all right? So, okay, we're all smart here, I believe. Okay, so that's it for like variables and types. Now let's talk a little bit about functions. We're almost done, I promise you. Yes, we're almost done. Almost done with the boring stuff, anyways. Okay, so what is a function? A function in programming is basically, let me just read this last, okay? Although I don't like to, but I wrote this. So a function is a reusable collection of related but smaller actions. Taking a dump, you can put it into a function, right? So step 1, walk into the bathroom. Step 2, turn on the lights and the venting. Step 3, you can I say that? You take your things off. Step 4, you sit down, and step 5, you make a noise or something. So that could be a function, right? And let's say you want to program taking a crap. You want to let's say you're building some kind of matrix, right? And you want to define actions for the humans. It would be annoying if every time someone takes a dump, you have to copy and paste the code. So instead, you can enclose that into a function. And then every time you want someone to take a dump, you just call that function instead of copy and pasting all the steps. So it's like an abstraction of a set of actions, right? Like a grouping kind of. If anyone use Photoshop, that's not a good analogy. Okay, so let's talk about starting your car because that's more normal, and not that taking a dump isn't. So functions can manipulate variables and call other functions. So you can functions is essentially a code block. You can do whatever you want with it. Like the rules are the same within and within and with, not without, but like inside and outside of functions. It's just a code block, right? So we can try to define our starting your car function in Solidity. I totally didn't go through like how to start your car, but I think everyone knows. You walk to your car, you pull the door handle, yes, and then you get into the driver's seat, close the door, foot on the brake pedal, press start, stop, and your car starts, right? And we can write, and then this is how a function signature, a function declaration will look like in Solidity. Oh, it's really long, but don't worry. So function, it's just to denote that it's a function that we're dealing with. Start car is the name of the function. And this pair of parentheses is basically, it's something called, I don't even know what it's called, but inside of here, you're able to pass information into the functions. I'm gonna show you that in a bit. It makes more sense that way. So parameters that function takes in. For this one, we have none, just for the sake of simplicity. Only owner, what does that mean? So only owner is what's known as a modifier. Now, what is a modifier? This is specific to Solidity. A modifier is a small code, a small snippet of code that's run before the function contents are run. And as you can tell from the name only owner here, we run this to ensure that only the owner of the car can call this function. And if it's not the owner of the car that's calling this, then this function will not execute. Modifiers are basically mini functions. You can think of them that way. And there are no built-in modifiers. Like you have to define only a modifier called only owner somewhere else in the code. Right? Public is the visibility of the function. And visibility basically it dictates who is able to call it. So there are 4 different visibilities in Solidity. Those of you who already know how to program, it's a little bit easier to understand, but those who don't worry too much about it. So there is, so starting from the most restricted, I would say, it was internal. Internal means that, actually not internal, it's private. So private means that only code that's within the same contract or class is able to call it. And again, this is like some programming stuff. If you don't have programming experience, don't worry about this part. Private means that only the code that's within the same class can call it. Not even your children when it comes to inheritance. Internal means that both the class itself and its children they're able to call this function. Public is the least restrictive. It means everyone can call that function. And then we have external. External means that only people outside of this class and its children can call it. Like only external actors are able to call it.
What's the difference between public and external?
For public, your code that's like, for public, you can call public functions within the same contract, like within another function within the same contract. But for external, you cannot.
External is
Only outside of this contract. Yes. Yes. And the very last bit returns bool success. So each function, every function has the capability to return some value. And here we're just returning. So again, it's like the variable thing, right? Whatever we're returning is a Boolean. What's its name is success. So I'm basically returning if the car has started or not, kind of, if it's successfully started. This entire line is also known as the function signature. Yes.
What's the purpose of having external?
Having what? Sorry.
External.
External. Sorry. So external. External is actually cheaper to call. So
I was thinking like read functions are maybe external.
not necessarily. Sometimes not necessarily, but yes, most of the time, yes. So so external functions are cheaper to call because they don't have to generate a function interface for like internal uses when you have everything compiled. But we can worry about that later. Like you can feel free to use public on everything. Like at this point, like I'm not like I don't want to like I'm not lying to you guys, but I'm just saying that we can wave our hands over some of the stuff for now, because otherwise you can go into really go into these rabbit holes and then kind of go off on a tangent. And, as we write more stuff, it'll make more sense. Everything will kind of fit together. Yeah. And the entire line is known as the function signature. And in Solidity, actually, they determine the function signature. So when you call a function in Solidity, the way that it kind of checks if this function exists is that the function signature is generated by, I think, hashing the entire thing, or just like the name and the parameters, and then compressing it into 4 bytes, taking the first 4 bytes, I think. I think that's how they do it, but we don't have to worry about this. But just know that this entire thing is called a function signature. That defines what a function is called, what it takes in, what are the prereqs, if you will, and then what does it return. Yes. So let's talk about modifiers. Modifier that we just had called only owner, right? So what a modifier, as I said, is a mini function. It's a function that's mostly used to check conditions. Sorry about the poor formatting, but this is how a modifier in Solidity will look like. Just add a new line here, and a new line here, and a new line here in your head. So modifier only owner access. Require message.sender is equal to owner. And for those of you who don't program, 1 equal sign means assignment, assigning a value to something. 2 equal signs is comparison, comparing if 2 things are equal. Yeah. So we have message.sender. So we require that whoever the caller is must be the owner, and this owner variable is previously stored in this contract. Otherwise, it gives this error message, and then close parentheses and next line. And this is only in modifiers. Underscore. Semicolon. That basically means that basically tells the compiler that this is like the end of the modifier. This is where the actual code of the function kind of you can think of it as like the actual code of the function gets copied in place of this, copied here. So basically, this is a check. It checks first, and that at the very end, you actually go to the actual function. Yes. So only interact. So this is the name of the modifier. So this require keyword. What does it mean? A require is a built-in keyword. It basically evaluates if whatever is in here is true. If it's not true, it reverts the entire transaction. Now, this is also something that's a little bit different from conventional programming in Solidity. In conventional programming, your program might fail halfway during a function call or something. And when it fails halfway, you kind of left with a dirty state sometimes, because let's say you're halfway through modifying some data, and then it crashes. But then the latter half of the data hasn't been modified because it crashed. But then the first half, they already have been modified. But that's not the case in Solidity, and the majority of, I would say, all blockchain programming languages. All calls are what I call atomic. Atomic meaning that it either happens or it doesn't. It's all or nothing. So it either succeeds and everything happens, everything goes through, or if it has one error, it would crash. It wouldn't crash. It would throw the error, and then it would basically roll back everything that you've done before, as if it never happened. Right. So that's a way to ensure the integrity of the data that's stored in the blockchain. So that's what require does. We use it to check some condition. Right. What does message.sender equals to owner mean? So this is basically, as I say, our defined condition. In this case, message is a global variable that's provided by Solidity. And in message, I think there are three different things we can look at. The first one is sender. So that basically tells you who called this contract, who made the call. Like a message.sender basically returns an address, an Ethereum address. It could either be an account, like a user, or it could be another smart contract, because smart contracts, they're able to call other smart contracts, right? And then there's also message.value. So let's say I'm sending you 1 Ether. The message.value would be 10 to the 18th, because remember, it's like in the smallest unit, and there are like 18 decimal places. So it's 10 to the 18th if I send you 1 Ether. That's what message.value is. It's the amount of Ether that's contained in this call. There's also message.data. I think that's just the raw call data that you don't ever have to worry about. And again, we defined owner earlier on. And we'll talk about this in a bit. And this on-off, you can define this message. So whenever it crashes, it reverts. Revert is the keyword here. Whenever it reverts, this message will be given to whoever that called this function, to basically let you know like what went wrong, right? And this means this underscore means you've reached the end of this modifier without any reverts. Feel free to proceed to the actual function, right? Anyone have any questions on these? Feel free to ask me. All right. This is how starting kind of look like. It's still like terrible. It's terribly written, but it's just to demonstrate you can call functions within functions, and you can call functions within functions within functions. There is a limit. Eventually, we'll talk about it later. More keywords that we have. They want to know before we go to actually write some code. Okay. First thing we saw a pragma. Did I pronounce it correctly? Pragma. So pragma. You always see in contracts. The first line, very first line, pragma solidity 0.8.0. What does it mean? It defines the compiler version that you're going to use. And this is important because different compiler versions, because Solidity is such a new language that it's still very much actively evolving. So like throughout its evolution, its syntax actually has changed a bit. So depending on your compiler version, the same piece of code may work in 0.5.0, but it might not work in 0.8.0, like it wouldn't compile. So you use pragma solidity to specify which version of the language you're trying to use, right? So, and view is a built-in modifier. It basically says that so any function with a view modifier means that function is read-only. It doesn't write anything to the blockchain. And the compiler will actually recommend you to slap this keyword on if the function is read only, because read only function calls in Solidity, they do not cause any gas. Read only function calls, they don't cause any gas. All right, only write functions do. And pure is it's one step further than view. So view only reads from the blockchain. A pure function doesn't even read from the blockchain. So like basically a view function is independent of the blockchain. So let's say you have a function that just returns an integer and you just type return 1 + 1. So that has nothing to do with the blockchain, because 1 + 1, it doesn't matter which contract you're in or what the state of the world is, it will always be equal to 2, right? So that function has nothing to do with the blockchain almost. So that's known as a pure function, right? Let's not worry about abstract. Not worry about override. Let's not worry about events for now, and let's not worry about interfaces for now. Okay, so there's that. Next up, let's start writing some stuff. Yeah. So let's go to everyone. So everyone go to this website called remix.ethereum.org. How do I make my screen bigger? I mean, like scale it up. I think we can do it.
I think on Chrome too, you can like command plus.
I know, but I'm trying to zoom in this one. I guess I know I can.
I know
do
that's not like.
Yeah. Just type remix, Ethereum remix into your browser, and let me know when you guys are ready. All right, my fellow Trojans, or Trojan users. Trojans, are we all kind of on this page more or less? Right. You probably saw something different than what I have here. You can just close the home thing. Don't worry about it. And you can just click anywhere to. It will come with like a few built-in contracts. Don't worry about those. Just create a new file by clicking on this button. I'm gonna make it bigger still. Humongous. Perfect. So let's click this to create a new file, and let's just call it debt tracker or something, because that's what we're gonna do today. It's the interesting. And the extension is .sol. That's the it does not mean how many days you spend on Mars. It stands for Solidity. No one got the Martian joke? All right. Okay. So we've got debt tracker. Let me know if you guys are ready for this. Not for this, but if you guys. This is like wait, what is? Oh. So they zoom independently? I didn't know that. All right, so let's go. So first thing you have to remember, we said we have to define a Solidity version. And in this case, let's see. It's the web page. So this remix thing is what's called an IDE, an integrated development environment. Is that what it's called?
Yeah.
Yes. So you can basically write code and run your code, deploy it, test it, mess with it, all in this browser environment. The great thing about this is that setting up a local Solidity development environment is actually, it's not as annoying anymore, but still a lot of work. But here you can just run it inside the browser. It's really simple. Right. So let's just write pragma Solidity. And it's at 0.8.7, so I can write 0.8.7. Or what I can also do is that I can write 0.8.0, but add this kind of up arrow. It means that any version any version that's above 0.80, that doesn't have breaking changes, like this file can work with that. So this is like a little bit more flexible, but if you want it to be very specific, you can remove this and specify that it has to be this specific version, but I'm just going to use this, right? And you might see like this, the web page automatically adjusting the compiler version. Like, look at how many versions there's been. Starting from 0.1.1, now it's at 0.8.9. Yes. And the next step is we basically have to define the contract. Yeah. So we just write contract. So that's you can even think of this as a variable. What's the type? It's a contract. What's the name? Debt tracker. And then you open bracket. And there you have your first smart contract that does absolutely nothing. So it's more like a dumb contract. It's a waste of space contract. That's what it is. That's our debt tracker contract, right? And let's just take a moment to think about this. All right, we want to track debt, and tracking debt. What does it involve? It involves a lot of like IOUs, right? So let's say, Mr. Titan, yes. Let's say I owe you $20. How much information do you have to write down on your notebook to track it? Yes.
I was gonna ask a question. Are we only concerned with the total amount of debt a person has accumulated, or are we concerned with keeping track of like the individual IOUs that a person has?
Well, we can do that with events, which we skipped over. We'll come back to it later.
Okay, yeah, it was just a question. I feel like that also matters in terms of.
Yes, it does. It doesn't matter as much in terms of design.
Okay.
If we rely on events and indexing services, but that's like for much later.
Okay.
Yeah. So right now we're just keeping track of in total, how much do I owe someone? Randall, I owe you 20 million. Not 20
Sounds
anymore,
about right.
20 million. 20 times 10 to the 18th, right? How many pieces of information would you write down to track that?
You need to have like the person and then how much money is like in their name.
Yes. So you would have my name,
Yeah.
the person who's in debt, your name, so you're the creditor, I'm the debtor. The debtor?
I don't know.
Okay, so anyway, the person who's giving out money, the person who's lending money, the person who's borrowing money, and how much the person borrowed, right? So 3 pieces of information. And that almost sounds like a job for mapping, because you can map, we can basically create a map where. So by the way, 2 slashes means the comment, so you can write whatever you want there. Ignore the, I don't know what the pop-ups are. Okay, so we can track. So okay, yeah. 3 pieces of info. By the way, you don't have to copy this. Lender, borrower, amount owed or something, not owed. Right? Does everyone agree? Yeah. 3 pieces of info. Okay. So how do we store this? We can think back to the mapping thing, right? Look at this one. Can we do like can we have, so in here we're mapping a number to a string to a Boolean, but maybe we can do it where we're mapping the name of the lender, the name of the borrower, and then to eventually how much the borrower has borrowed from this lender. Does that make sense? Yes.
Have we talked about structs yet?
No, we haven't. Let's save that for later. Yes.
So if I structure the map like that, how would I be able to pull a piece of information if I like just have, so if you're going lender, borrower, amount,
Yes.
how would I be able to pull borrower from lender if I have one? And it's like the second in the map, it's embedded in the
So
second.
if you have a borrower, so what are you trying to pull? So the total, are you trying to pull like
So you need a key to get into the nested map.
yes.
What if I have the person who's in the nested part, but I can't go, like I can't find the
Yes.
upper layer.
Yes, but then this is not limited to smart contracts. So let's say everyone knows everyone money in this room. And if I just ask you how much do you owe? How do you answer that question? Because I didn't tell you who do you owe some who do you owe money to or something. Or am I asking you the total or like you gotta give me more info, right? So in terms of total, there is a way to do it. We just need like a set, we can add the second mapping to keep track of the individual, like the total ones.
Or like a separate one.
Like a separate mapping, like you can even have like a reverse mapping where instead of doing lender to borrower to amount, and then you can do borrower to lender to something. But again, but if you only have the borrower, you can only go down one level and you still won't know like what are you trying to look for.
So is this like the best data structure to use for this use case? In Solidity at least.
It's it's the one that's kind of off the top of my head, so it must be the best. I don't know. I think it's because it's such a simple one. There isn't that much room to optimize. So I think this is like acceptable. All right. So let's write the mapping, right? So we're going lender to borrower to amount owed. So it'll be lender maps to borrower maps to amount, right? So the syntax would be mapping. And keep in mind, lender and borrower, in this case, they're simply addresses. Because on Ethereum, your identity is your address, right? So mapping address points to another mapping and maps another address and points to U256. That's the amount owed. And you can give it a name, call it set mapping. And that's how you declare a new mapping. And the great thing about this ID is that if you make a typo somewhere, it will actually tell you what's wrong, right, in real time. So that's quite good. Okay.
So mine is all like italicized, like is that like normal?
What do you mean?
Like it's all it's like a
Okay, your comments.
oh it's like
Yes, yes.
You do it outside the
The
comments.
font's different.
What?
You do it outside of the
The font's different from yours?
Like you have it
It's
inside.
italicized for everyone else, but you got, like, it's just a different font.
So just take it, delete the two slides.
Oh, yeah. Oh, this is probably Windows or Mac, I think, or maybe, I don't know.
Is that just like Ethereum?
Are you trying to copy
Yes.
the mapping?
Public address,
yeah, I'm
yes.
trying to like like do one
thing you know, we're
Let's see. Yeah, that's because it's a comment, it's not code. It's like a comment. And read two slides for comment. Because you have to tell, this is like your,
doesn't mean anything.
yeah, it doesn't mean anything.
Oh, so this is fine.
This is for human reference.
Oh, okay.
A comment is something that's for humans to read, not computers.
I see, that's that.
Is the era just like a equal sign?
Equal sign and then an arrow, yeah.
So this is basically like a hash table within a hash table.
Yes.
I mean, this is like, so it's like,
Yes. Big brain. Oh, that's hey, industry tech.
Oh, I was just curious about the end of line 9, debt mapping.
What?
The end of line 9.
The end of line
The debt mapping, what does that mean?
Oh, that's the name of the variable. Like that's how I will refer to it later on.
Like the end of. This would be like.
Okay, is everyone good with this thing? Yeah.
The most smart contracts are like this, mapping, parentheses, address, and then arrow.
Well, this is just my custom mapping thing. It's just like, it's just for this use case. I can show you what our Unsigned smart contract looks like. It's not the one. Is this the one? This is not the one.
Insider information.
Yeah, you all have to sign an NDA.
This is the result of 401.
No, it has nothing to do with one. So this is the Unsigned smart contract. It's like 900 lines, or 800 something. And yeah, this is like, so a crap ton of mappings, see modifiers, functions. Yes, and this is not the only file. There are like more files. Yeah. Yes.
So is Solidity strictly for the Ethereum blockchain or? is it-
Yes, Solidity is a language invented to write smart contracts on Ethereum. There's another language that you can use called Viper, but I've never seen any human being use it, or non-human being for that matter.
I also want to add like that there's something called the Ethereum virtual machine, which is basically what like processes and runs its code.
Yes.
And there are other, because Ethereum was the first mover, became so popular, the Solidity language became so popular, there was a lot of dev tooling and basically support for this language. So then a lot of other chains to basically kind of gain traction quickly, they made EVM compatible chains like Binance Smart Chain, Avalanche. These are examples of EVM compatible, which means, or like Polygon too, which means it's incredibly easy to port your Ethereum Solidity smart contract onto this new chain. And it basically starts up the ecosystem on that chain quicker because for like Solana, or example, you have to know Rust and learn this entire new sort of smart contract development, which means takes a lot more effort. There's much more of that initial hump to get sort of applications onto that.
Yes, yes. Yes, thank you for that. And also, actually, after the variable name, we can optionally add a visibility. I say optionally because if you don't add anything, by default, by default, is it public or internal? I forgot. But it does, let's just make it public explicitly. So it's easier for us to wait. Oh, okay, sorry. Public should go before, I think. Yes, okay. Sorry, visibility should go before the variable name. Okay, so just make it public so that if you make it public, it's easier for us to test it in a bit, and you all see why. Right. All right. So next up, so we have our base data structure down, right? So what else do we need? Now that we have the data structure, we need to write a few functions, or we need like, let's say Randall, he's keeping track of this ledger that like who owes who money. What are some of the actions you can do, right? So you can ask him, let's say he's like the record keeper, you can ask him, if you can ask him information about who owes who how much, right? So that's one thing you can do. You can also ask him to write down, okay, this person now owes me, this person borrowed like $20 more from me. You can tell him that and for him to kind of add it to the record book. You can also tell him this person gave me money back, gave me however many dollars back, and you can subtract it from the debt. So they're kind of, so you can think of it as 3 different functions in total. So I'll type this down. So function 1, get info, get amount owed. How do you word this? Yes, owed, is it from? Or is it by? From by. Forget it. Amount owed.
We get it from borrower to go under from borrower.
Yes,
It looks like.
whatever. Get amount owed, like given lender and borrower, how about? Yeah. Then function 2. Add debt to borrower as lender, right? Because I can't just say that now Nicholas owes Randall $20 more. I can't just state that because if I say that to everyone, like I can say that about everyone, but it's proof, right? So you want the lender to say that, okay, this person now just then he can show you some proof maybe, but we just want to limit it to that. We want to limit it to this so that only the lender himself can call this function and add that to a certain borrower, right? And then the third function is to remove debt from borrower as lender, right? That also works. Or even no, it's not this. It's remove debt as borrower. Yes. Yes, let's do this. This is more interesting. Wait, add debt No, let's do this later. Let's do this later because I don't want to talk about sending money yet. It's a little bit more complicated. Okay. So in this case, this is like a total, like no transaction, like no monetary transactions go through this smart contract. We're only keeping track of who owes who how much money in the real world. In the simulation. So let's write the first function then. Right? Okay. Get amount owed given lender and borrower. Right? So let's declare, let's just write function because we're declaring a function now. And we can just name it get amount owed. Not owed. Owed. And then we're given a lender and a borrower. And remember I said that, well, I kind of skipped over it, but yes, I said that inside the parentheses over here, you're able to define what parameters or what data the function takes in. In this one, we have none. But here we need to take in the address of the lender and the address of the borrower, so we can kind of traverse through this mapping and find the amount owed, right? So in order to do that, again, you're seeing a pattern here. It's the type, and then the name. Type, name, right? Type name, and these you can call it whatever. You can call this type or something. It doesn't matter. It's just something that you need to, something you tell yourself, like you're telling yourself what it is. The computer doesn't care about the name, right? And we actually want it to be external because we never call it within this function, and being external saves a little bit of gas. And gas is the execution cost. So because the entire thing is decentralized, like if you in the conventional programming world, if you want to put your code on like a cloud server or something, let's say Google Cloud Platform, you pay GCP money for them to run your code. But in a decentralized world, you can't really pay anyone. So every single line of execution actually costs money in this case, that's what's called gas fee. Think of it as a car. Like the more gas, like the further a car has to travel, the more gas it will consume. I hope that makes sense to everyone. Yes.
So how does it being like public actually take more gas?
So with it being public, because a public function can also be called within this contract itself.
Yeah.
It has to generate an inner-facing interface, and also an outer-facing
Either has
interface.
to generate that.
It has to generate two,
Oh,
basically. But external, because you cannot call it within this function. You can only call, within this contract. You can only call it from an external source. So it doesn't have to generate the inner-facing interface.
oh.
So it uses less gas.
Yeah, on deployment, usually. Yes. I was waiting for someone to say, what if you drive a Tesla?
Oh.
Okay. So it's external, right? And also because we're only getting how much is owed. We're not trying to modify anything. So just a reminder, if we're not trying to modify anything, then we can use a view because it doesn't write to the blockchain. We cannot use a pure because we're still reading from it. We're trying to read who owes who how much, but we're not writing from it, so we're using a view, right? External view, and then because we're trying to get the amount owed, we want to return something, and we can return because it returns UNT256, right? And open brackets. That's basically how you kind of. That means like we're done with the function signature. Now let's get into the function body. All right, and you can add a name to it. Or you don't have to. Like if you add a name to it, you don't have to explicitly say return 10. You can just do like amount equals 10. It's a bit interesting in Solidity. Like no other language does this, as far as I'm aware, as far as I know. But let's just not do this for the sake of like. Let's not make it confusing. Okay. Does this line sit right with everyone? Everyone knows what it means more or less?
So what you're saying, when you said
we're not gonna worry about that, but like, let's say you did do that, does that mean you don't need a return statement?
Yeah, you need a
Or it's
return, you just
whatever
assign a
amount-
value to that variable.
it's just whatever amount is by the end. of
Yes, yes, and you're actually able, you like, if you do that, you're able to assign a value first and then do some extra work. Yes. Okay, does this line make sense to everyone? If you have any questions, shoot now, because it will get progressively more confusing. Yes.
Can you say what view means again?
View means that this function will not write to the blockchain, it only reads.
All right.
It's read only,
Yeah, yeah.
so it doesn't cost any gas to call it.
Can you repeat why it has to be external?
It doesn't, you can make it public.
But external just. means
So,
cheaper
okay.
gas.
So external is cheaper because I believe external is, I'm not sure if external is cheaper when you call it, but I know for a fact that external is cheaper when you deploy your contract, because in order for a contract to call, in order for your code to call some function, the function has to generate an interface to inform of the other code, what's the name, what it takes in, what it returns, right? If you do public, what's the difference between public and external? External can only be called from the outside, whereas public can be called from both the inside and the outside. So for public, you have to generate two sets of interfaces, whereas for external, you don't have to generate one, because you don't have to worry about it being called internal. So you generate less information, you store less stuff on the blockchain, so that equates to less, like a cheaper deployment, like slightly cheaper deployment cost. Yeah, but you can also, so that's mainly how it is. You can leave it as public, it's fine. We're using fake money here, it doesn't matter. Yeah. Yes.
Oh, so I'm trying to understand, the outcome of this, line, right? So.
Which line?
No, this function.
Okay.
So what actually, I have no coding experience. What will make this happen? What is the outcome?
Yes, I will go through it right now. So it will just return whatever amount is, it will return the tail end of this mapping. So remember, we're mapping from lender to borrower to amount. We're trying to get to the amount. So we need to know what the lender is and what the borrower is to kind of, progressively kind of, get to the, like quite literally get to the bottom of it.
So we're trying to get it to the true?
Yes,
Okay.
we're trying to get to the third layer.
And right now we are giving them a name or giving them an address.
Yes. So we're given these two pieces of the puzzle, and we're trying to get to the last one. In order to get to the last one, you need to know what's before it, right? Yeah.
Were we getting lender and borrower inside the parameters?
Where are we?
Yeah.
The caller has to supply it.
Okay.
Yes. And we'll show you how to do it in this. Anyone else have any questions? Fail, okay. That's it? All right, let's get to it. Okay, so let's remind ourselves of how to get to the bottom of, let's say, again, if we try to get to this true here, and we're given these two pieces of these two keys, the way we get to it is the name of the mapping, the value of the first key, the value of the second key, and then that returns the final result, the final third value. And that's exactly what we're going to do here. It's really easy. So we can return right away. Return debt mapping. So now we want to do the lender first. Lender, and then borrower, and that's it. That's it.
You have to see if they exist or not.
If it doesn't, it'll return 0. Yes, because they're automatically initialized to the default values. There are no nulls in Solidity. They're all just default values. Yes. Does that make sense? So we're just kind of going down like layers of this mapping and to get to the bottom. Yes.
So it's default value for all types of all variable type 0.
Okay, so let's find where did I? Yes. The default value for an address is the 0 address, so all zeros, 0x0000.
Yes.
For bytes 32, it's the default value is an empty string. That also represents like a zero bytes. Default value for bool is false because underneath the bool is actually a uint 8. So 0 means false, 1 means
Zero is
true.
false.
Yes, uint is 0. And mapping doesn't have a default value because in order to use a mapping, you have to combine it, you have to use it with these.
Mapping of some type.
Yes, and the default value would be the type. The default value of the type.
Going back to like where you're saying about like public and like external.
Yes.
What does it like look like when it's like called internal?
Okay, I can show you. I can show you in a bit, yeah. But does this make sense more or less to everyone? We're basically traversing the mapping to get to the bottom of it, yeah.
So if I give a lender and a borrower that don't exist, it's not gonna throw an error.
It's just gonna give you a 0, yeah. So the moment you declare this mapping, all possible combinations are all initialized to 0. And then you modify them to give them value. Yes. It's interesting how it works, kind of. It doesn't literally initialize everything to 0, otherwise it'd be like huge. But like it interprets it that way. If it doesn't exist, then it's a default value. Right. Any other questions? Everyone good? Okay. So this is our first function here. What's going on, man? All right. Okay, so now that we have the first function down, we're trying to get the amount owed. We have that. We can actually try to run it. You know what? It's pretty cool. So click on this. You guys all have this logo, this icon on the left? Because they change things around. I don't know, like by default, how many it shows.
It has like a rotate.
Yeah, same.
It means it's compiling probably, right? Kind of. I don't know. Let me see. A rotating.
So it needs to be compilation like this thing.
I clicked on compile.
Okay, so
and it came
click
like
so
one.
so click on that, and then turn on auto compile. Turn on this option. Click on that. Turn on auto compile. All right.
What does the one mean?
The what?
The one.
You scroll down, there's one warning. So orange means warning. This is just like a licensing thing. If you want to fix it, just copy this. I can't even copy it. Let me copy it. Like it's fine. Don't worry about this. It's like a licensing copyright thing. Don't worry. They added it recently. They used to like they want you to explicitly state the license. Like if you want it to be open source, is it MIT license or is it?
Oh, yeah.
Yeah. Because you know the nature of blockchain Solidity is like open collaboration, right? So they really want you to specify like what do you allow, what do you want others to do, and what do you not want others to do. But for our purposes, it doesn't matter, right? Is everyone good on this? See?
I got it. Oh.
Like if you have an error on some line, let's say spelled it wrong, you can see in red X here, and it'll actually show you what exactly you typed wrong. Like with the arrow. Yeah. Right. Okay, everyone's good here, right? So let's go to let's click on this one. It looks like Ethereum with the play button, right? Everyone's here? Yep, okay. So leave the environment as is. Leave, and you can see all these accounts here. We're so rich, right? Sally or Shake. Don't worry about this either. So let's just make sure that the contract selected is dead tracker. I know that like if you open Remix for the first time, they give you like the balance or something, storage. make sure you choose debt tracker as your contract. I only have debt tracker because I deleted everything else. All right, debt tracker. And then click deploy. All right. You see it, you can see at the bottom here, it's expanded. And you can already see, right? Why is it showing my super old address? That's like where I lived before I transferred to USC. No, like way before. Okay. So debt mapping. Okay, so we need a lender's address and we need a borrower's address. All right. So you can get some addresses really quickly by just scrolling up to your account. You can see that this is no longer 100 Ether because deploying and doing anything, any writing on the blockchain costs money. This is how you can see it. And you can just copy this address, all right? Copy it, and then you can paste it here, get amount owed, comma, use comma to separate the arguments. Or you can click on the down arrow, it'll give you a nicer UI. So let's say like, okay, so how much do I owe myself? And by the way, this is different for everyone. The address is different for everyone. So let's say how much do I owe myself? 0. So you see it gives you the default value if there are no entries. This is the result of 0.
Wait, where do you copy and paste the
Here.
account?
Scroll up to your account and then this little copy icon here.
Yeah.
Click on it and just copy.
That copy, Command V will paste it.
Yeah.
Oh, really? Automatically?
Now you have to Command V
Oh, Command V on
to
the.
paste it. You like click the down arrow to expand it.
And then you paste it into there.
Oh.
What happens if I put my actual address in?
Nothing will happen because this is a fake blockchain running inside this browser environment. Nothing will happen. Your account will have 0 balance. Yes.
I want to add like 100 Ether.
Oh, that's within your browser. You can daydream.
So wait, did you copy that and put it into both lender and borrower?
Yes. Yes. How much am I borrowing for myself?
You can try combinations of other
You
addresses.
can do whatever. Like you can switch to a second account, copy it, go back to the first one, or stay on the second one. Doesn't matter, and then use a different one. It will still be 0 because we never entered anything into it, right?
So it's by default just giving you a bunch of addresses on the test net, or does it not have to do with test net?
This is not even a test net. This is running inside your browser.
Oh,
Yeah. See, it's a JavaScript virtual machine, like literally within this tab. Yes.
So there's another thing above it that says debt mapping, is that just, if you're able to. add
Yes.
to the
Yes.
map,
You are actually able to, like, if you declare it as public,
you can add to
you can only read from it.
that. Oh,
So if you expand it, like these two essentially do the same things here. Choose 0.
oh.
So, but only in this IDE. It doesn't work anywhere else. But only in this IDE, if you have variables public, they put like global variables public, not global, but if you have variables public, you will like it will generate what's called a getter for you. So a getter means a function that gets the value of whatever's in it.
So the same thing we just built.
Yes. Yes. But it's only available within Remix. It's not available anywhere else. Yes. This is like a nice little like beginner friendly thing that Remix is doing. Yeah. But in the real world, you have to write them yourself. So let's not worry about this one for now. Okay. So it's returning 0. It works, no crashes. Let's move on to the next function. Yeah. So now we're gonna add that to the borrower as the lender. All right. So again, function, right? Let's call it add debt. Add debt. And in this case, what we want is we need who the borrower is. So we need 3 things still. Who's the lender? Who's the borrower? And how much are we borrowing? Right? How much that person's borrowing. But you're adding that to the borrower as a lender. So so the problem with like if I do address lender, address borrower, and then U256 amount. The problem with doing this is that I'm too thirsty. This is actually really good. Like I hate coconut water with passion, but this one's really good. Okay. Okay, so who sees an issue with this?
anyone can just add,
Yes,
it doesn't matter.
yes. What's stopping me from making Randall owe me $30 million? Because I owed him 20, so now he has to owe me 30. But yeah, exactly. What's stopping me from modifying, or what's stopping me from saying, okay, Nicholas now owes him 20 million? Right? If I can do that, then I can do this to everyone else. Like if it's just me and Randall, then that's fine. But I can essentially define who the lender is, who the borrower is, and make things up. Right? So we don't want that. We don't want that, right? And one of the things that we talked about in the slides, so we basically want to make sure that, because as we said here, what this function does is that it adds debt to the borrower as the lender. So we want to make sure that the caller is the lender. And how do we make sure that how do we use the caller's address as the lender?
Modifier?
Huh?
You mean a modifier?
Close. Close. Yes, I know. You're on the right slide. Yes. Yes. How come this guy knows all the answers? Yes, message.sender. Remember, I think it was on this slide. No. Functions. Yes. Message.sender. Remember, I said message is a global variable that basically that basically represents the incoming transaction. It has sender, which is who's calling it, value, which is how much money they're sending over, and data, which is the raw call data. And then what we need in this case is we need message.sender, because we want to make sure that the caller is the lender instead of defining who the lender is. So we want to get rid of this, all right? And let's just keep writing it. So it's got to be it's public again or external. Let me make this external, right? And this time we don't have, it's not view, right? Because we're modifying, we're adding things. We're making modifications to the blockchain. So it's no longer view. And let's just return Boolean for returns actually. To see like if it's successful or not. We can return true at the very end, right? Okay. Or even better, you know what? Let's return the total amount of debt that's being owed by this person, right? Okay. So now what should we do? Now let's do this. I'm trying to think if I should use shorthand. Yes.
Is there not a keyword that you're supposed to use to say that it's going onto the blockchain?
No. By default, like if I remove view here, I'll get a warning saying that function state mutability can be restricted to view. So by default, if you don't add anything, it assumes it writes. The compiler detects that, hey, you're not writing anything. Why don't you call it a view? So if I add a view, it disappears. Yes. Yeah. So by default, without anything, it means it writes. That's the assumption. Yeah.
You make sure that it's not added to the blockchain, right? You just make sure that it's not added.
Yes,
to the
and like if you have a write operation here, if you have a write operation here, like if I do this, see, it will say that function declare this view, but this expression potentially, like if they're not very confident, modifies the state and thus requires the default whatever, like modifier or something. So yeah, so the compiler makes sure that you're not doing anything stupid. Yeah. Okay, so let's move it on. I actually just typed the answers there. Okay, so what we can do is, again, we have to access the mapping, obviously. And first we have to get to the lender because it's lender to borrow the O2 amount. And we can use message.sender. Yeah, and you can see it's like a different color because it's a keyword. So, you know, because we're saying that we add debt to the borrower as the lender. So the caller would be the lender in this case. So we don't specify it, the caller is the lender. And we're also given the borrower.
Yeah, from. I'm trying to.
What?
But yes,
What?
what you typed in there.
Yo.
Oh, no.
I was like, someone has to come over and take a look at my screen because it's showing this. That is, I've never seen that happen. That's so weird. Okay. Okay, so now we have the borrower. Oh, sorry, the lender, the borrower, and then we want to because we're adding debt. We want to add to the existing debt. All right. So there are two ways of doing this. I'm going to do it the longer way and then the shorter way. All right. The longer way is to assign the current amount of debt to a variable. We saved it to a variable, okay? And now what we want to do is we want to add the new amount to the current debt. So debt plus amount.
Since the function of the public, you can show like calling the function within the other.
Yes, I'll do it. I'll do it in a bit. And then we can do just copy and paste this. We can assign this equal to debt. This is not necessary, but this is like very clear. Does everyone understand what's happening here? So I'm basically getting whatever the amount of debt that we currently have. I'm saving it to a variable, and then I'm adding the new amount. I'm adding the new amount to the existing debt, and then I'm setting this mapping value to the new kind of debt thing. Or I should even name this new debt. I think that might make more sense. Yes.
Does plus equals operator will do this?
Yes, I'm going to show that in a bit because I wanted to, because I wanted to accommodate everyone. Does everyone more or less understand what this is doing?
Yeah, I just get like the message.sender part too.
Yes.
Yeah.
Yes.
Yeah, so the sender in this, sorry, the message or sender part, like, so instead of putting down the lender,
Yes.
like, why do you put down?
Because I'm trying to make it so that only I'm trying to make it so that I can only modify the information of my borrowers, not of some other people. Like if I add another parameter called address lender, then I can basically make modifications to other people's debts. Does that make sense?
And message.sender is the address of the person calling that function. So you as a lender call this function, and then it'll take your address, which means it'll go to the first mapping, and then you can only add to the debt to a borrower that you specify of you being the lender, because you're the one calling this function.
Yes. This is not the most secure way of doing things because you can still screw someone else, but at least you're only screwing your borrowers, more or less. Well, I mean, you can still screw everything.
Using this function,
I was just trying to demonstrate message.sender.
but using this function, you can just like add that to anyone. Right?
Yeah.
You can just be like, you're in that.
Yes, but then they will know you did it.
And then they'll add that to.
Yes. It's like the feds. No. Okay, so we have this, right? But this is obviously pretty complicated. So a way to simplify this is to simply take this and use the plus equals operator. All right. So okay. So these are the same. The 3 lines up here and this 1 liner here, they are the same. They do the same thing. So plus equals means that it takes the current value. Plus equals means it takes whatever this is, adds this to it, and then assigns it back. So this is shorthand for these 3 lines. This is the shorthand, the plus equals operator. And you can also do minus equals, multiply equals, divide equals. Yes, not fun. Yes, there's fun. Yeah.
I think you could also split instead of those 3 lines.
Yes.
Equals debt mapping plus amount.
Yes. You can also do like debt mapping equals the entire mapping thing equals the entire mapping thing plus amount. Yes. I'll write that down. So many ways of writing the same thing. How exciting. Yes. All of these, like these three, separated by a blank line, they're all the same. They all do the same thing. Exactly the same thing. And this is like the shortest one, the easiest one. All right, so I'm just going to comment out the other ones, but you can still see it. And to comment really quickly, just command and slash. Right?
So all those other ones that you just commented are synonymous to each other, including
Yes.
the one that you left out.
Yes, yes, they are the same. And because, again, remember we're returning something, you see, without returning, it says that like, you know, you haven't, you said you're gonna return, but you haven't. Broke my heart. Right? So let's return, right? So let's just return, we're gonna return the new amount of debt. So we can just copy and paste this. Yes, that'll be it. This one. Does that make sense to everyone? Let me know if you have any questions.
So for the other part, when you like try to test it out, so you have to like choose which account,
Yes.
and then you deploy it, and then you like paste in the account address, and
Yes.
it's like the thing, you call it, and then it'll like take
Yes.
money from that account.
It won't take money yet. We're not doing any money
Like
taking
gas.
today. Yes. That's like the transaction.
That's for deploying the contract.
Oh, yeah.
That's deployed, so the con.
And also calling any non-view or
Yeah,
non-pure
right.
functions.
Do you know how expensive it is compared to like AWS or like normal?
Really
Quite
expensive. We just deployed a couple of contracts like 2 weeks ago and it was like 0.6 ETH or something. And these were like small contracts.
0.6?
Something like that.
Our e-sign contract costs 0.2 to deploy.
Really? Well, we had a
Gas was
couple.
really high.
Yeah, gas was really bad too, so I don't know. We didn't write the most optimal too, like it definitely could have optimized.
No, but we had a crap ton of like open Zeppelin libraries. I don't know. It could be the gas fees. Like I know it fluctuates a lot.
Yeah, but regardless, compared to AWS GCP, it's like very.
But you're trending, you're decentralized.
0.6 on the block.
0.6 Ether, yes.
Cost to deploy a smart contract.
Deploy a couple, yeah.
Yes. Mine costs 0.2, so now you know who's better program.
Exactly. That's why he's teaching it and I'm just sitting on the side.
It was 2 contracts.
Yeah, it was 2, it was like 0.2 each, 0.3 each, yeah.
Yeah, okay.
That's not track.
Does this function make sense to everyone? Yes? I need some affirmations. Yes, okay. I like the thumb. Thumbs up.
But what if the borrower doesn't exist? Is that
What if, what?
break it, or is it just not doing it?
What do you
If
mean?
the borrower doesn't exist, that's the one you.
Oh, well, just, what do you mean by doesn't exist?
Like, what if I like say that this person owes me money, but they're not even in the data structure. Create one.
Well, by default, no one's in the data structure. Yeah, so like if it doesn't exist, it just adds, like it defaults to 0 and then, you know, it adds from there.
So like you're also creating the borrower.
Yes, so
like,
you're also
account
creating
for
it.
Oh,
Deploys only happens once, right? With a smart contract.
Yes.
But if you want to like edit your smart contract, there are ways to like.
Upgradable with proxies is too complicated.
Yeah, exactly. Most of the time you just have to redeploy because they're like, the whole point is them being immutable, right? So,
Upgrading is also redeploying
yeah.
with some other.
Is it like
caveats. It's like you have a middleman contract that basically holds a reference to whatever implementation you're trying to use. And if you want to upgrade, but the middleman holds the storage, but uses the implementation's logic. And you want a new logic, you can deploy a new one, make it point to the new one, and still uses the same storage. But then you also have to make sure the storage is compatible. So you can't delete anything. And when you add variables, you have to be careful. You can only add to the end. So it's lots of, you know, complicated stuff that we won't get into. Yes. Take 356. I don't think we're gonna get to that, to be honest. Not even in 356. Okay. So now we have add debt. Next up, we're gonna do remove debt. Honestly, we can literally just copy and paste because it's just instead of adding, we remove. And of course, I have to rename it. That's all we have to do. I'm just gonna do. That's literally it. It's, full format.
Well, how did you untab that?
Ah, shift tab.
Oh, you don't have to read the front of the line to shift tab?
No.
Oh, I always click and then I shift tab. I didn't know you can do that.
But for yeah, see, for tabbing, you have to be, but for shift tab, you don't have to. Does this make sense to everyone? It's just like the only difference is instead of adding, you're subtracting. Instead of a plus equals, you're doing minus. Mr. Titan, I have a question for you. As the industry titan, do you see a problem with this? Subtracting to an unsigned integer?
You can go negative.
That is unsigned.
Oh, because you can't store a negative.
No, there's no. Think of your CS 356.
I know, I'm CSV.
Okay, okay. So let's say. Okay, so so the problem is that this is not related to smart contracts, but it is kind of related. So for an unsigned integer, let's say of 2 bits, right? So 2 bits, 0, 0, okay? Stop. Okay, so the max value is 1, 1, and that would be 3 in decimal. Right? So how do I calculate this? 2 to the 0 times 1 plus 2 to the first times 1. So it's 1 plus 2. That'll be 3, right? Now that's the max value, and then the min value is 0, 0, obviously. But what happens if I try to so if I try to subtract 1 from 3, what would happen is that I would get 1, 0. Right? I'm getting 1, 0 because. Well, because if I subtract 1, you know, I don't know how to explain this, but you literally just get 1, 0, right? Because you start, it's like decimal subtraction. You start from like the rightmost digit, and then you work your way towards the left. But because it's -1, so you just knock this 1 down by 1, so it becomes 1, 0. What happens if I try to subtract 1 from 0, 0? You knock 1 down from 0, turns into 1. And then you carry that over, knock this one down by 1. 0 becomes 1 again. So 0 minus 1 equals 3 in this case, because it wraps around. It's outside the range, so it wraps around to the max value. Does that make sense?
It's not a U2, it's like a U2 or something.
UN2, yes, 2 bits. It's a 2. Yes. So it wraps around. Makes sense. And you see the problem here. And this problem was present in earlier versions of Solidity compiler, where if you have to check that the value you get from subtraction is actually smaller than the original value. Because because it wraps around, so you can totally screw someone if they pick, if imagine if you're paying off your debt, you pay too much, and then you owe like $90 million, right? That's what happens. That's what used to happen. But so it used to be where you have to check if the result is smaller than the original value. But now in the newer versions of the Solidity compiler, if you subtract too much, it will just revert. If it detects it's what's called an underflow.
So it doesn't wrap around anymore.
It doesn't wrap around, it just reverts. It detects that internally. It used to be that it wraps around, which is terrible.
So you might revert, it just sends the money back.
No. It reverts as if it rolls back the entire function call as if nothing happened. This is what's called an underflow. An overflow is if I try to add +1 to 1, 1. What would happen, right? If I +1, I would normally, if there are no bit restrictions, I would get 1, 0, 0, right? Because if I +1 to 1, it becomes 0. And carry 1 over, 1 plus 1, 0. Carry 1 over 1, so it's 1, 0, 0. And 1, 0, 0 is 4. Because 0 times 2 to 0, 0 times 2 to 1, 1 times 2 to 2. But we only have 2 bits. So deleting 1 will be omitted. So what would happen is that 3 plus 1 equals 0 now. See, so that's what's called an overflow. So you're going over. Yeah. So we don't have to worry about this. I'm just saying that in older versions of Solidity, that was an issue. And there was actually a library called Safe Math that kind of just does the check for you. That's what, and lots of people used to use it. I can actually show you that library here.
Oh, so you say like the bits, if you add something, it might be even more bits. So it's just like,
But because we have a bit restriction, because there's only 2.
so then the next one would be like 3 bits. And that's bigger.
Yeah, and you would cut off the leading one, and then your 4 becomes 0. 3 plus 1 turns into
So
0.
if like the sum has more bits. than one.
Yes,
That's how you get, that's what underflow and overflow.
Yeah, it won't fit.
You have too many, the number you're like, the new number you're creating doesn't fit in the range of the, like this.
Look at this, all right, guys. Take a look at this one. This is Safe Math, the Safe Math library, right? It tries to add. See, it adds A to B, saves it to C. But then it checks if the sum is smaller than the one of the numbers. If it's smaller, it means that the number was too big to wrap it around. So it basically returns false, but it really reverts or something. Yeah, I think it reverts. And then that's try add. Try sub, this one subtracts. So it subtracts A from B. Yes, it subtracts it subtracts B from A. But then if B is larger than A, because they're unsigned, you can't go negative, you can only wrap around. So if B is larger than A, you're subtracting B from A, then it kind of just, it reverses, really, that's what it does.
Are those returning functions?
Huh?
Are those returning pairs?
Yes. Sorry, I forgot to mention this, but you're able to return tuples.
So in the case of the last function,
Yes.
we don't want it, let's say we don't want it to wrap around because we don't want someone's dead going to 0, then back up to max or whatever.
Yes.
It is. Are there if statements in Solidity that we can use?
What statements?
If statements,
Yeah.
like if. So we can say if it like do some condition where if it wraps around, we.
Yeah, so you save the original balance before you modify it.
Yeah.
You get the new one, you compare them if one's bigger or smaller than the other. Yeah, but we don't need to do this because in version 0.8.0, this is already like handled by the compiler, by the runtime, so you don't have to worry about it. Okay, so now we have this. Let's try to get this. Let's try to wrap it up. Let's try to get up before 10. Okay, so let's go to this tab again, right? And let's click on the trash can icon to delete the previous one. Okay, and then let's click on deploy again. So we're deploying the new debt tracker, right? Expand it. Now you see we have a lot more functions here. Okay. All right, so let's add some debt. All right. I'm gonna. Yeah, this is fine. Okay. Let me refresh this. New file. Let me copy and paste the addresses here so that I don't have to keep switching. Let's do like 3 of them. Okay, let's go back to the first one. All right, so let's add that to your borrower. Okay, and keep in mind this is I am currently using this address. So this is message.sender, the first one. All right. So I want to add that. You know, let's give it names. I'll do Jack. Yes. Okay. So right now, message.sender is Jack because I'm on this account. Okay. I want to make it so that Titan owes me. Let's just do 20. All right, let's just do 20. Okay. So click on transact. And nothing I can do here. How does this even work? Like my cursor is being tracked, but then the feed isn't? What? I don't even know how this works. I've never seen this before. Okay. So I already clicked on transact. I already did that. So now let's take a look at the amount owed. The amount that the amount of money that Titan owes me, right? See, we got 20 because we added 20, right? And if I do 30 here, this will, the bottom one will hopefully become 50 because we added 30 to 20. Transact. And then call. Now it's 50. Yeah.
If we didn't want someone, so we have get amount owed and debt mapping.
Oh, okay. So
Let's say if we don't want someone to be able to use debt mapping, because they're the same thing, would we make it
private
we make it private?
or internal,
Internal?
private or internal. Okay. Yeah. Yeah, that's a good idea. That's a good idea. Because otherwise, it's just too many things on the screen. Let me delete this. Oh. That's a bit cleaner, yeah. See, now if it's internal, then you know they won't be able to see it. Okay. Well, let's add more debt to Titan. Let's do 50. You can't run away. No. Oh, I almost added debt to myself. Okay. So now let's see. That's the 50. All right, we got 50. So our add debt is working. What about remove debt? We want to remove 40, right? Transact. And then let's call again, it should be 10, and indeed it is 10 now. Okay. So okay, so what if we try to remove more? Let's do like 20. There's only 10, so we can't remove 20. Let's see what happens. See, there's an error. Let me show you in the console. The transaction has been reverted, right? So basically, it's not allowing you to subtract more. It's not allowing you to go into negative numbers. It's not it detects that like it's going to underflow, so it reverses the entire thing. All right. So honestly, yeah.
If you put, for example, 50 for 60, it will detect it also as an underflow or
Sorry,
an overflow.
which one?
So if you put 50 above and then 60 at the bottom,
Yes,
is that going
yes.
to be an overflow or not?
Under. Overflow means that the number is trying to go beyond the cap, the max value, so that it wraps around to the min value. Underflow means that it's trying to go below the min value, so it wraps around to the max value.
I keep getting errors when I call. Is that because I keep using, I'm using the same address as borrower?
That shouldn't be an issue. Let's see.
Also, like something you guys can do like after tonight's build night, if you guys are like interested in it, is like you can try to modify the remove or the subtract debt function like with a conditional, so that if the amount you're subtracting is greater than the amount you owed, you just manually assign the value to 0 and return 0 instead, which would like slightly improve behavior. And you can like also, I'd recommend changing around some of the keywords and see what happens when you change something from external to this. And if you can call it or make an internal function, you can kind of just play around with it after as well.
Yes.
Just to.
I
to
will
get a little
teach
more
this
hands-on.
Huh?
I was gonna link crypto zombies after this for them to like keep like learning that.
It's a bit too early to assign homework assignments.
Yeah.
Yeah, but really just understand what's going on here. Next time we can move much quicker because I don't have to explain the keywords and terminology.
So
yeah.
Sorry. Do you put the slides in here?
I have a YouTube channel. I talk about it on my channel.
Okay.
Let me. Yeah, just search for Head CP on YouTube. That's my YouTube channel.
What was it? Link it in the Discord thing.
Yes, link in the Discord too.
What was the name?
Head CP.
HEAD
Yes,
CP.
Head space CP.
Head.
Yes, Head.
we can't get these slides regardless.
Oh, you could. I'm going to post it.
All the
Yes, I know. This is the one.
Oh, really?
Yeah.
Say like.
Is that like the new one that just came out?
No, this is, I bought it in January.
Oh, okay.
The file, it's the contract, and then dot, whatever is the function. But if you call the get, it would say, get tracker dot remove get, so I don't think.
Yes.
Now it says
256 is available for next semester.
There's also 356. It might not be listed right now because they're working out the hiring details with me.
Oh.
Yeah, because I'm gonna teach it.
This is.
Yeah.
I have a
What's that
2020,
class gonna look like?
So I'm probably not. for a while, but-
You're basically gonna end up building a smart contract that from start to finish, like from the Solidity side all the way to like the web interface. It will happen for sure. It will happen for sure.
Our gas fees.
You run local. Yeah. Or there are test nets. where you can get free.
Like how do they?
They're much more centralized and they're like, no, honestly, they're.
Which test that you?
It's the only one that gets the only one. I don't have.
We use it on this. They have like this.
Yeah, right now I have.
Oh, yeah. Yeah. I know that bitch.
It's like the most.
Oh, yeah.
This is really helpful. They're doing something pretty similar, much more like aggressive and a much more like fleshed out project. The point of really was for like